Hello all and welcome back. So in this video, let us now move forward and solve some more questions on DP. Now the question which we have to solve is a very famous question which will help us in clearing a lots of concepts when we will be dealing with DP questions in future. The question is minimum cost path. Now let me explain you the question. So question is something like this. It says that if you are standing here and let's say you have to reach to this last cell. Okay. Say we are starting from here and we have to go till here, we have to tell the minimum cost path. Now, let's say you can, in a very easy manner, think of these as a toll or some fees which you have to pay, which are written in front of you. You will start from here. You could have gone to three like this. You could have gone like this as well. But we have to make sure that we tell the minimum path. Okay, minimum path, cost path, where some of these numbers is going to be minimum. Okay. Seems like this exactly is the path. If we take this path, I will be able to reach to my minimum. Right, everyone? So here the sum is 1 plus 2, 3, 3 plus 2, 5, 5 plus 3, 8. Here it would have been 9 plus 3, which is 12. Okay. So the path seems to be something like this. Okay. Which is our answer. We have to just tell the minimum cost path. Now, the question is written here as well. So let us read this because it is very important to understand if the same will be given to you in any competition or any online assessment, how we will be understanding this one by one. So you have a cost matrix. Okay. Again, it's just a 2D list. We are aware of this. And you need to find the minimum cost to reach a specific position MN. Now we are taking this position as 3, 3. Again, we can take it as MN as well. Starting from the top left corner, which is 0, 0. Each cell in the matrix has a cost that you need to add up to get to the total cost for the path you take. Okay. So the path which we are taking, we have to keep on adding that cost. You can only move down to the right or diagonally down right. This thing is very important to understand. It is saying that you can either move right or you can move down or diagonally in this direction. Okay, so this is right, this is down, and this is diagonally down right. So these are just the things which we can move. And again, that is very important because if we would have moved, let's say in some other direction, then our solution might change. Right, everyone? So these are some constraints which you have to understand very patiently whenever any question is given. Now, tomorrow a question can ask you that, hey, you can move in all the directions. That is fine as well, right? Maybe that can help you to reach a solution quickly. So just the approach will change, but the idea, the intuition, you should be forming from these type of questions. Now, this is clear. You keep in mind that all costs are positive integer. We are given the same cost matrix here. M and N are 3, 3, and it is asking us to minimum cost. Okay, great. So let us see now, everyone, how we can reach out to this particular code or the problem. Again, you have to make sure that first we write down the recursive solution. Then we see if we can apply memoization or not. And if memoization can be applied, then we can use tabulation as well. Okay. So that's the approach which we will follow, everyone. Now let us see how we will majorly be solving this question. So if I am at a particular, let's say matrix, let me draw it like this. Let me draw it 3 cross 3 only, the one given in question. We know that it is in a way a 2D list. Okay. So let me redraw it nicely. Yeah. Here, this is the zeroth, 1, 2. So in terms of rows and column, 0 and 0, we have to start from 0, 0, first row and first column, and reach to, let's say, 2, comma 2 in this point, but should be fine, right? Great. We are standing here. Now let's see what are all the directions. I can either move in this direction or in this direction or in this direction, right? So let me just write it down as well. So let us just scroll a little bit down and see directions in which we can move. Okay. So again, first is on the right. To move on the right, what we have to do, everyone? I think if we have to move on the right, we can do two things. Either we can say that, hey, I am on 0, 0 as of now. If you have to move on the right, then your column is increasing and row is same. Okay. So now we have to talk a lot in terms of column and rows. These are your overall rows and these are your columns. Okay. So now if we see, if one has to move here, the row is same, but column gets increased. Okay. Or we can say one more thing as well. If we have to reach here, then let's say I started with mn, which is 3 and 3. We can just reduce this n by 2. Okay. So I will repeat this again. What exactly am I saying? We are starting from 0, 0. Okay. Now, if I have to move in this direction, then n and m are my values where I have to reach. Can't I say here that, hey, I am moving a step closer to my column because this is n minus 1, right? Because if my m, this is 3 comma 3, okay, then I can say this m and n. Here when I move with respect to this final location, n is going to be 2 because I have to subtract 1 from that. Okay, so when we will write this in code, it will become a lot more clear. Just a different way of thinking. You can either say that, hey, I have to go 100 kilometers. Let's say if you are standing here, okay, and this is the destination, which is 100 kilometers. This is your destination final. Now, either you can say that, hey, when you are standing here, you can say that, hey, I have walked 20 kilometers or I have covered 20 kilometers, or you can say that, hey, I am left with 80 kilometers. Now, first approach you must have done a lot of times in many questions in this course as well. I want to make sure that you understand using second approach as well. Okay, great. So yeah, I think that is clear now, everyone. This is where we have to apply for right. So we have to make it 0, 1. Second is down. When we have to go down, that means we have to increase the row and column will remain the same. See, we are standing here. If we have to go down, increase the row, but this column is 0 only. And when we have to go diagonally, then third, diagonally, both of them have to increase. Okay, so great. Cool. So now what we will do? What is the overall intuition now once we have written all these things? See, we will just call recursion on these parts and say that, hey, get me the cost if I am taking left, down, or a diagonal step. Recursion will get me the cost, and I have to make sure that I take minimum of all these costs and add the cost where I am standing, and I will get my answer. Okay. So recursion will have to do the major work. We just have to make sure that once we have all the cost, because if you think in a way, I can just divide this question like this. What if I start from here? Then how much, let's say, what is the cost? What if I start from here? Then what is the cost? And what if I start from here? Then what is the cost? If all these costs are given to me, if I get the answer for all these costs, then I can just add minimum, add my cost to the minimum of these three. We just have to handle one case. That is, if you are standing here, either we have to make sure that we don't make this call, okay, because here we cannot go, right? This is out of our grid. Or we have to make sure that we either return some very large number like infinity, so that when we take the minimum, this whole thing is eliminated. Okay, so I will repeat it again. Let's say when you have reached at this particular position, either don't make this call, check if where you are standing, if it is basically in the overall, if it has a right step or not, if it is possible. Think of it as a mountain. If you're standing on the cliff of a mountain, of course, you cannot take a step. Okay. So either don't take the step or just look down and see that, okay, it is very deep. So either we will repeat that, hey, it has an infinite cost here. Okay. So even when I get the answer as infinite, I will not be taking this in my final answer. Okay, everyone. So pretty sure that the question and the intuition is clear. So what I want all of you to do now is in your coding exercise, try this question out first by just writing the recursive code, something which we will discuss in the video, and then going forward, we will see how we can write the code for other overall memoization and DP technique as well, and if they will be applicable or not. Okay. So great, everyone. Let's meet in the next video. Till then, please make sure that based on our discussion, you are able to write the overall recursion code for this problem.